Alright, welcome back. So in this video, we're just gonna go over two examples that we're gonna apply KCL, KVL, and Ohm's law to analyze our circuits. So we have this circuit, we have a 15-volt solar source, we have R1 and R2. Their values are 5 kilo ohms and 10 kilo ohms. And we're asked to find the voltage drop across R2 or VR2. So first off, I'm gonna assume my voltage notation. So for R1, there's a voltage source right here, and I know its current is gonna go this way. It's gonna go from the positive back to the negative. So I'm assuming that if current is flowing this way, this is the positive and this is the negative for the resistor R1, and same for R2. So that's the first step. You should always specify the sign convention that you're going to use for your question. And now they're asking for VR2. So just when they ask about voltage, I should really think of Ohm's law. So we know that V equals IR. So VR2 is equal to I times R2. I know the value of R2, but I don't know the current. Now, how am I going to figure out the current that's going through the circuit? Because it's just, the current has only one way. We don't have any other branches. So it's the same current everywhere. It has nowhere else to go. So the way we're going to do this is by applying KVL. So apply KVL, which states that the total voltage across the loop, by this sign I mean I'm going clockwise across around the loop that I have right now. So the total voltage around the loop equals to 0. So if I stick to the convention that I made right now, the clockwise direction, I'm going right now from negative to positive in this source. So this means I gain 15 volts. I go from a lower voltage side to a higher voltage side. I gain 15. So it's positive 15. And then I keep going. And then the current goes through this resistor. And it goes from the the positive, down to the lower side, which is the negative. So this means there's a voltage drop, hence the negative sign. Negative I times R1. And then I keep on going. The current keeps on going, and then it comes to this resistor. It goes from the positive to the negative, from the higher potential to the lower potential. So again, I have a voltage drop, hence the negative sign. So negative I R2, it all equals 0. So now all I gotta do is just replace the numbers that I have. So I have 15 minus, I can take I as a common factor just to make my life easier, then R1 plus R2 equals 0. And then 15 minus I into R1 is 5 and R2 is 10, so the total is 15 equals 0. Now this means that I equals to 15 over 15, which equals to 1 milliamp. The reason why it's milliamp, it's not amps, is because I have kilo amps. So if you're confused about that, you can just convert it back into normal, kilo ohms. I don't know if I said amps. So just convert it back to the regular ohms. So R1 in this case would be 5 times 10 to the 3 ohms, and R2 should be 10 times 10 to the 3rd ohms. So if you replace that, you're going to end up with 15 over 5 times 10 to the 3rd plus 10 times 10 to the 3rd, and this should give you 0.001 amps, which is the same as 1 milliamp. So basically the first step you have to do is just identify the sign conventions and then kind of breaking down the problem that we have. Now let's go to the second example that we have right here,